Hello, everybody. Good morning and welcome. And thank you so much for joining us this morning for this webinar. We're really excited to bring you this topic. It's a topic that I'm personally very passionate about. Well, anything that can make the manufacturing industry in the UK even more innovative is a personal passion of mine. So welcome. So is generative design really the future of CAD? Now, that's the topic of today. So thank you for joining us. Now, we're obviously using Zoom, and I'm sure after the last couple of years, you're all pretty used to using Zoom. But if you're not, please use the Q&A box at the bottom of the screen whilst we go through the presentation. If you have any questions or comments, we'll be happy to either answer them while Cameron's presenting, or at the end live if we've got time. So thank you for joining us this morning. So without further ado, let me introduce myself. So my name, for those of you that don't know me, is Simon Brand, and I'm the sales manager here for Man & Machine. And my contact details are on the screen. I've been in the industry for a long, long time. So hopefully some of the names on the list I recognize. So thank you for joining us this morning. So this topic is all about Fusion. Now, Fusion Generative Design. Now, for those of you that were with us a couple of weeks ago at our previous webinar, when we spoke about how to use Fusion and what Fusion is all about, Fusion is essentially a platform. Now, if you think about the traditional design to manufacturing to sales sort of process, normally or traditionally, this has been done with a variety of applications each doing a specific task. Now, what Fusion does is it's a complete platform, allowing customers to be more innovative across platforms and potentially one person doing the job that traditionally would have been done by 3 or 4 people. Really exciting platform, and it's certainly, I believe, the future of where CAD/CAM is going in the future. So everything completely integrated, seamlessly integrated, allowing better collaboration and better innovation. That's what Fusion is all about. And I'm really pleased to bring you this second in our series around the generative design extension. Let me explain how Fusion is packaged for those that don't know. So Fusion, if you think about this sort of traditional applications that a normal design or manufacturing company needs to do, you can't quite see that one that says visualization behind me. If you've maybe got to do CAD and CAM and PCB design, a bit of simulation, a bit of visualization, traditionally these would have been done with a different application at every stage. And that could have been the same person having to remember how to use these different applications, or quite often it was different people or different teams of people using each set of tools. Now that has a cost effect to the business. And in the world that we're in today, more and more of you I know are being tasked with doing multiple elements of the design to manufacturing process. So what Fusion does is it allows you to do all of this plus more, including subtractive and additive manufacturing and styling, as well as data management, all within a single integrated platform for a very affordable price. £365 is the current price. Well, actually, there's currently, I think it ends today or tomorrow, there's currently a sale on at the moment. It's even 20% less than that. But right now, you would pay £365 a year for a complete CAD, CAM, PCB, simulation, visualization tool, all in one box. Wonderful technology. Now, what they've actually done on top of that is for those individuals that perhaps need to do a little bit more machining, maybe, take it to 5-axis machining or nesting and fabrication. We have these extensions that can either be used on a consumption basis, a pay-as-you-go type use, where you buy a number of credits, and the credit's about £1 a credit, something like that, and you simply use them or spend your credits as and when you need to use them. So if you're doing something once in a blue moon, you need to access generative or additive manufacturing, advance or machining, you simply use your credits on a pay-as-you-go basis. Alternatively, if it's something you're doing more frequently, what you can do is subscribe to these extensions like you do for your Fusion on an unlimited basis for an entire year. So generative design is one of these extensions that you can either use at a pay-as-you-go, or if you're doing it quite often on a subscription basis for an entire year, completely unlimited. And they're very reasonably priced, and there's even a sale on at the moment, exactly the same as Fusion. So really exciting. So to explain a bit more about what generative design actually is, because it's been around for a little while, and I think a lot of people are confused about where to use it in real world. But the way that we see generative design is it is essentially artificial intelligence. Now, if you think about your own business and your design to manufacturing, to sales, to management and service sort of process, I bet you every single element of your business over the last 5, 10, 20 years has seen improvements, has seen, moved forward and become more efficient. The one bit I feel that hasn't moved forward is that initial concept stage. If you think about it, you're coming up with an idea, you've got a new project, and the designer, the engineer, has to solve that challenge using his own mind. Now, normally that might be based upon something that he's done in the past, tweaking it, changing it, trying to make it better or fit the new requirements. But to actually come up with something completely revolutionary, completely innovative, those sort of days, I think, haven't really seen many advances in recent years, in many years. And what generative design does is it really takes the power of infinite cloud computing and allows the engineer up front to solve the challenge that he sees in front of him and whittle down these solutions based upon the manufacturing process that he has access to. That's what it's about, and that's what Cameron Mackenzie is going to show you shortly. And it looks something like this. So, traditionally, right up front in the design process, the sort of light blue ones might be the normal process. You come up with a few designs, few ideas to solve your challenge. You then might simulate some of them with something like Nastran and eliminate the ones you don't want to do, and then take one design forward. But that's very limited in terms of the possible outcomes. What generative design does with the power of the cloud allows you to explore hundreds, if not thousands, of possible design solutions based upon the parameters that you feed into the computer. You can then, as a designer, whittle them down based upon your own processes, your capabilities manufacturing wise, or maybe consider how many you're producing. Is it one? We all know that the fewer the batch run, different processes become more or less profitable, more or less affordable. But what generative does is it looks at multiple different manufacturing processes right up front before even designs even been thought about, to consider the cost, to consider what is possible. Now, you may have access to additive, you may not. You may want to whittle them down and only select 5-axis or only look at 3-axis machining. But that's what you can do with generative right up front, right at the very start of your project. So to give you a couple of examples, this is an example of a customer that we have that makes motorbike crank arm, sort of holding at the front of the bike. Now, the design on the far left is what the human brain came up with, and that's what they've always done. It's a huge safety factor, relatively low cost, but quite heavy. And obviously with bikes and motorbikes and such, being lighter as possible is advantageous. So they used generative design and came up with these multiple different options here. Now, clearly, you can see from the results, the one on the far right, the additive one, is the lightest with the lowest safety factor, but of course, costs more. In the end, the customer went for the 2.5-axis one because it was readily available manufacturing-wise, relatively affordable, but significantly lighter than what the human brain came up with. So they were removing material. And we all know the cost of materials these days doesn't seem to be going down anywhere, and especially with what's going on in the industry at the moment. I think cost of materials going up even further is inevitable. And obviously, if we took a look at another example, the automotive sector. Now, the automotive sector, we all know, is going through a radical change at the moment, moving towards electrification and electric vehicles. And this is an example of General Motors, who have committed to designing and bringing to market 20 vehicles, fully electric vehicles, in the next 2 years. So it's a huge ambition they have. And what do we all think about when we're looking at electric vehicles as a consumer ourselves? We all look at the range of the vehicle, whether, you know, I'm doing 300 miles a week, right? I need a vehicle that's got a higher range as possible. And one of the biggest things with electric vehicles that affects the range of the vehicles, because the batteries can only take you a certain way, is aerodynamics, yes, but weight is a massive contributing factor to the range of an electric vehicle. So removing material and being as light as possible is very advantageous to the electric vehicle. So what General Motors have done is they worked with Autodesk to test generative design to see how far they could push it and whether the results that they were able to get were real, were genuine, could actually solve the challenge that they have. So they looked at this component here. Now, this is a structurally integral part of the vehicle. It's the seat buckle clasp. It's made up of 9 individual components bolted together, made of steel, quite heavy material, but it is integral. If there's an accident, it has to be able to withstand a huge force to save the passenger in the back seat. And what General Motors did was they used generative design to come up with ideas. Now, obviously, with generative design, and what Cameron's going to show you shortly, is you select areas that are integral, you know, the bolting holes, the mounting points, and feed in the simulate, you know, the real world simulations, in the real world effects that you're going to have to adhere to. And the computer will come up with, I mean, this is a small sample, but hundreds, if not thousands, of possible ideas that could solve this challenge. In the end, this was the final result, the piece that they actually moved forward with and will be appearing in some of their cars now, if not in the next couple of years. And when you compare that to the original piece, it looks organic. It looks like a bone, you know, it looks very weird and wonderful. I mean, obviously, General Motors had access to additive manufacturing, so that's why you get these very crazy, weird and wonderful shapes. But the end result was phenomenal. This piece was 40% lighter than the original piece. As well as that, it was even stronger. It was 20% stronger than the original design. And that's a great example, I think, of how generative design can really help the designer to come up with the best result. It's also one piece rather than 9 components. So we're Man and Machine, and what we do, obviously, we sell the software, but we're here to help support our customers with services, training, support, and deployments to make sure that any investment, big or small, you're getting the most out of that investment. And that's what Man and Machine do, and that's what we're here to deliver. Now, without further ado, I'm going to stop talking now, and I'm going to hand over to my colleague, Cameron. Cameron's the expert, the guru on this stuff, and he's going to be taking you through how to actually use generative design to get some results out of it.
Awesome. Thank you, Simon. Good morning, everybody. Welcome to our presentation today. So, yeah, as Simon was saying, we're just going to take a look inside of Fusion at the model that we worked in our previous demonstration and see what we can improve on this model itself using generative design. So the area that we've decided to focus on today will just be this swing arm here at the back of the assembly itself, and just to see what kind of results we can get out of the Fusion generative design, and just to be able to see if we can get any lighter, see what type of shapes we can get, and just begin exploring the options that we can get out of this. As Simon showed in some of the examples, a lot of the time it'll be able to simplify your overall model and just be able to make manufacturing that much easier, and getting better results out of it. So just talk you through the process and just show you how simple it is to get some really great results out of our models here. So to start this off, I'm just going to go into the model of the swing arm itself. If I select this, you'll see it's part of the rear suspension sub-assembly inside of this assembly itself. So I'm just going to open up that rear assembly from within here. And then inside of this rear assembly, we can see that this is just the swing arm part here. I've managed to just make a copy of it in the side here. So I'm just going to use this copy as part of our study itself. So I'm just going to open this up quickly as well. So you can see we've got the part itself open up. We've got the rear assembly, sub-assembly inside here, or the rear suspension, sub-assembly, and we've got the full part itself open. So they'll all be communicating throughout and between each other as well. So to get into the study environment, the generative design study environment, we'll just switch to the generative design workspace, which we can do so here in the top left. You can see we've got our design workspace. We'll just switch straight to generative design just by hitting the drop down and going straight in there. You'll see we met with the window asking us to create a new study where we can either create a fluid path, and in this case, we're going to create a structural component. So I'm just going to create the study here just with a simple click. And what this will do is it'll bring in the model from our workspace environment, or our design workspace rather, and then allow us to create a study from this model itself. From here, we've pretty much got two options. So as Simon described earlier, essentially what we need to tell Fusion or the generative design study is the areas in which we want to keep, the areas in which we want to have be attached as part of our main assembly. And in this case, for this particular model, we're just going to ignore this, the mud flap over here. Essentially, all we're going to want to do is create an area over here to attach our new swing arm to the existing assembly, to the existing bike. So we're going to use this hole over here where we're going to attach a bolt. We're also going to use these little areas down here to attach the suspension, and then we're going to use the slots over here to attach the wheels. And now to do this, we can essentially come in and edit this model itself. We could do this inside of the workspace, the design workspace, or inside of the generative design workspace. We've also got the ability to edit the model. So I'm just going to go straight into the edit model section. And essentially from here, we're just creating new geometry. So basically the same as in your design space, we're just going to make new geometry specifically for the generative design outcome that we want. So to do so, we're just going to create a sketch quickly on top of the areas in which we want to include in the space here. So I'm just going to create a sketch straight onto the surface. You can see we've created that sketch directly on there. I'm going to project geometry of the existing part, so we can use the existing part as part of this this creation. So I'm just going to use the outline of the profile of the hole itself, and just hit OK for this particular moment. And then what I'm going to do is just add a quick circle to the outside here. I'm just going to drive the dimension of this. And let's say we want this to be 10 mil, at least for the bolt to attach to. And essentially for this particular one, that's all I'm going to take for now. We're going to let generative design actually create the encasing for the bolt itself. All we need is a surface for that bolt to attach to. So I'm just going to finish the sketch on there. Nice and simple, create an extrusion of that profile. I'm going to do it in the opposite direction just to make sure we're going through. And instead of cutting through our model, what I'm going to do is create a new body out of this extrusion itself. So simple as that for this one, just create it like that. And then pretty much going to copy that same process along for each of the other attachment points. So I'm just going to create a sketch on that one. And if you do find that that the body or the component itself is getting in the way, as part of the sketch settings, we can slice the view itself just so we can see exactly the profile that we're needing to that we're wanting to apply the sketch to. So just going to again create a projection of that face, this time the whole face itself, and you can see that that remains in there. This particular point probably not going to make as wide as the last one, so we're just going to set this one probably about 5 mil. In fact, what I might even do as part of this one is just project the existing one and almost get an exact replication of the original shape here. So just going to add a quick line down here and maybe remove some of the the geometry from there. So you can see this is a direct representative of the original shape. So if I just finish sketch on here, just make sure that the profile is complete. Yes, it is. Cool. What I'm going to do now quickly is just create an extrusion of that. So make sure I'm including the outer rim of that and just extrude that out. Also, just going to eyeball it for now. It's probably going to be about 5 mil. Yeah, 5 mil looks great. So again, we don't want to cut this. We want to make this as a new body. And just hit OK on that. And then the last one I want to do quickly, as I explained earlier, is just the area in which we're going to attach the wheel. So again, I'm going to rotate the model around, create a sketch on that face itself, slice the view, just so you can see that nice and clearly. I'm going to create a projection of the hole itself. So to do that, I'm just going to select the surface, which should allow me to get that. Yeah, that's perfect. And then instead of trying to create the geometry itself, I'm just going to create an offset of that hole itself. Maybe just eyeball that again. Make it an offset of about 10 mil for that. Just finish off the sketch there quickly. You can see we've got that nice and clear there. I'm going to create another extrusion. Again, just making sure that I've got all of the entire profile selected, and then just extrude that out the opposite side. You can see this one's slightly thicker. Obviously got a bit more to carry. I just want to make sure it more or less matches what we had originally, which is about 10 mil. So that's perfect. Again, not a cut. Just going to get a new body and OK that from there. And now all we have to do to replicate that on the other side is to create a mirror of those objects. So I'm going to just turn off the original model just so we can see the new parts a bit clearer. So I'm just going to turn the visibility of those off, as well as the mud guards. Cool. So we've got our parts all set over there, the ones that we're going to have as our starting geometry or our included geometry. We're just going to create a quick modification and create a mirror of that. We're going to select the entire bodies quickly. And we're going to mirror this on the X, Z, the Y, the XY plane over here, just to make sure that that's the correct one. Yeah, the alignment looks good. And we can just create that. And you can see we've essentially got new bodies created for that. So if I finish the edit of the model here, you can see inside of our workspace over here, we've gone through the edit model. Now what we need to do is show you the generative design study, what we want to include as part of our design. And to do that, you can see we've got this preserved geometry here, as well as at the top here in our toolbar at the top in our ribbon. And essentially inside of Fusion, everything you do is all of the ribbons are pretty much laid out so that you're working from left to right. So any button you need along your way will essentially be to the right of the one that you've just previously used. So as long as you're moving from the far left all the way to the far right throughout your design process, you should essentially be able to touch on each button that you'd need as part of the design process. So the first one we want to do is obviously just assign the preserved geometry, and this will be the geometry we want obviously preserved as part of the study, so that would need to be included in the study. So in this case, I'm going to select those 6 bodies that I just created and just OK them, and you'll notice that those then turn green. So green is the preserved geometry, and you can see it's grouped them all nicely in this preserved geometry group here. You can rename that if you wanted to, otherwise we can just keep them over there, and we can toggle those on and off as we need. So the next thing we'll need is obstructive or obstacle geometry. And essentially what obstacle geometry does is that'll be areas in which you want to avoid. You don't want the generative design to kind of go into those areas. This will be for areas where you want to fasten bolts or you want to have attachments sort of come into the model itself. You can imagine we'd need some bolts to come in there, as well as the areas in which you'd want to try to get your hands in and actually tie those in or get a tool inside there. So we just got to think of those, as well as if you have a look at the full assembly, you can imagine we've got to include an area in which we want to have the suspension here. So we want to create pretty much a void in the middle of the design there for that, and the tire, I suppose. it might be a little bit awkward if you don't have space for a tire on the swing arm itself. So we want to create those areas as well. So if we go back into the edit model, what I'm going to do is quickly turn that swing arm back on, just so we get a general idea of where the areas might have been, where we want to kind of keep void. And then we're just going to pretty much model some extra geometry inside that we're going to include as obstacle geometry. So the first section I want to do quickly is the area in which the suspension will be set. So again, I'm just going to project geometry of the existing void. So I'm just going to project the edges along here quickly, as well as the final extent of those there. And just using those, I can just okay that, and you can see they're part of this the sketch now. So I'm just going to extend that over a bit just to make sure we don't have any areas, any rogue geometry going around the edges. And essentially just closing that profile. You can see Fusion gives you that confirmation that the profile is closed by highlighting that region or shading the region. So I can just finish the sketch on there. What I'll probably want to do is create a bit of a void over here as well, just to be able to allow the study to create some geometry in that area. So I'm going to go back into that sketch, which can be accessed here in the timeline, and just add a region in here quickly just for that. We can add any constraints we wanted to that as well. If we wanted to kind of constrain the positioning of those lines itself, I'm just going to eyeball it for now in this particular one, but you could come in and add some dimensions to any of the lines, make sure that they are a certain depth, make sure that you've got a certain bit of excess void area over there. But for this particular one, I'm just going to finish sketch on this. Once I'm happy with that, I can just create a quick extrusion of that profile again. I'm going to, instead of it being a one-sided, I'm going to select two sides, so one side can extrude a little higher than the other. Just make sure that we've got this aligned correctly, so that would be the top there. Perfect. So I'm just going to have the top come out a little higher than the bottom needs to be. Awesome. So again, this is, instead of a join, this is going to be a new body that we're going to create as a solid obstacle geometry or obstructive geometry. So creating enough space there for our arms to come in, and then we'll add a bit more obstructive geometry in a sec. The next thing we want to do obviously is create a wheel, or a representative of the wheel itself, and we're going to just create that on the XY sketch plane. I'm going to project the existing geometry again, just to find the center, the two centers of the wheel, just to make space for both sides, depending on how you place your wheel there. So if I just finish that projection, and we're going to make that more or less 520 mil on both of the from both the centers. I'll then quickly create an extrusion. This time a symmetrical one. Create it as a new body. Make sure that it fits more or less within. I can go to the back view quickly. Happy with that, so that you can just hit OK. Now, obviously, that's intersecting where we want our arm as well, so we can just modify this quickly, add a bit of a chamfer to it on each of those edges. Make sure it's the edges selected, not the profile. That's fine. Bring that in a little bit. Probably want to have a two distance one. Let's view this from the top quickly. Bring this out a little bit, and bring this in quite a bit more. You don't have to make the obstructive geometry too detailed. Pretty much just make it as detailed as you need, and you obviously want to create areas that you want the final design to avoid. So don't worry too much about proper detailing of the object. But obviously we want to make as many smooth corners as possible or smooth edges as possible, just to make sure that you don't have any jagged sections on the final render or the final design. So if we just create a quick fillet on those edges there, if it will let me follow along. Yep, too far. We could zoom out a little bit. There we go. I'm happy with that. Last one quickly before we move on to the next section. Just to neaten these off a bit. Zoom in a bit. There we go, nice and smooth. You can see it'll leave, if we view this directly from what's currently the back view, you can see it's left quite a nice area over there for it to develop whatever it needs to and avoid any of the wheel itself. So once I'm happy with that, I can just add some connector obstacles. So this is essentially where you'd be creating your nuts and bolts that would be able to be considered as part of the study itself. And you can see we start off with the shaft of the object itself. We can extrude that all the way through, and then we can add a bolt head as well to the opposite side. We can adjust the thickness of that as well. And then just to compensate for any extra space that might be needed to put the bolt in, we're just going to extend that out a bit on that one there. We're going to do the same on the inside over here as well. Again, just to make sure that we've got room for those. That extension should be fine. I'll just go a little further and add a bolt head. And obviously this is going to go into the other obstacle geometry, so we're not worried about those two intersecting each other. And the last one, I think this one will probably need a custom design for this. So I'm just going to add a quick sketch on top of this surface here. I'm going to, again, project the geometry of that slot. And then I'm going to create an extrusion of that as a new body. And one last one quickly. Another extrusion of that as a new body. Probably extend this out a little bit more just to make sure we've got the room for it. I wanted to then just combine those two just so that we know that they're going to be created as one part. So it's going to combine those two individual bodies. And then again, just mirror these across. So I'm going to go into the create mirror and mirror those custom bolts along that same XY plane. Again, making sure new body is selected rather than join, just to make sure we don't run into any issues. Once we're happy with that, we can just finish sketching. You'll notice the ones that were created as the obstacle bolts, those are essentially automatically assigned as obstacle geometry. So they will be avoided automatically. Those that we didn't create, those that we created on our own, we'll have to just assign as obstacle geometry as well. So I'm just going to use that same process, selecting the obstacle geometry button, and then just going to add the remaining, I think it's just the 4 objects, just making sure, and then the wheel, obviously. And you can see we've got all of those selected. So in total, we've got 8 objects, which pretty much matches out. We've got the 6 bolts and then the 2 areas in which we want to avoid. So that's essentially that for the geometry side. We could add a starting shape as well, which I'll get into in a little while. But essentially all we need to do from now on to get this design ready for our study, I can just turn off that original swing arm again, just so we can see what is left. And you can see all of the green is the preserve and all of the red is the obstacle. From here, all we need to do is then apply some constraints and some loads, essentially, just so Fusion has an idea of what we're wanting to get out of the study itself. So to add a constraint, this will essentially either create a fixed, a pin, or frictionless constraint onto any objects inside of this. And these will be the objects that we don't want to move, or we only want to be able to move in a certain direction. In this case, we only want to apply a fixed constraint to the pin here where we want to attach this to the main part of the bike itself. So I can turn off the visibility of the obstacle geometry quickly, and I just want to apply a fixed constraint to the center of that one and a center of the opposite one. And you can see that that locks it in, so this won't move in the X, Y, or Z. I can hit OK on that. And once it's thought about that and shown us everything again, we're just going to turn off the obstacle geometry again, just to apply some loads onto each of the other the preserved geometry. And now this is what essentially will build up our design. This is what we're telling Fusion that we want this final design to be able to withstand. We want it to be able to withstand loads on these connector points, in which will obviously bear the brunt of most of the movement at a later point. With this other area here sat still, the rest of these will essentially be moving towards and away from that origin point, essentially. And we want to be able to create a structure that will be able to withstand any of the movement that will come across from there. So the first thing I want to do is actually assign the there is a gravitational load that's already assigned. I just want to make sure that that's pointing in the right direction. You can see here it's not pointing in the right direction. So we can go into that by expanding the load case over here, going to our loads, and you can see we've got our gravity load here, our gravity load. So essentially what we can do here is we can change the direction of this, changing the angle of that over here. So just to make sure that this is pointed in the right direction, I just want to make sure we can change that, and we can adjust that by moving this dial around. And you can see we want to push that to about 90 degrees because it was off by about 90 degrees. So if we're okay that it should be pointing straight down, which is essentially what we want out of this. We notice how using that existing geometry, we've managed to get a few different levels to the final design here as well, which is quite handy. And you wouldn't have been able to do that very easily without using that existing geometry. So sometimes it is worth using something that you've already got, unless you're wanting to completely overhaul the plan itself. Anyway, back to applying the structural loads, we can come in here. And essentially all we have to do is select a surface in which we want to apply the load to. So obviously the pins are going to be set inside of this surface here, and we can also apply the direction of that load itself. The direction or the direction type can be set to be normal, so that it will be applied on the entire surface, directly normal to that surface itself. It can also be set at an angle. In that case, we've got the 3 axes in which we can rotate this direction in. For this particular model, we want to obviously just have this pointing down. Let's get the orientation right, just so I can see which direction it is, more or less, I suppose, at a bit of an angle to what the gravitational load will be, considering the suspension arm will most likely be here at probably about a 30-degree angle or so. So maybe push it off to 195 degrees for that one. We can also then assign the magnitude of the load itself. You've got a few different units that you can use. By default, it assigns the magnitude in newtons, but we can come into the drop down here where we've got pound of force, we've got an ounce of force, or a ton of force. For this study, I have to set everything to a ton of force. And in this particular instance, I've set it to about 200 kilograms for that. So 0.2 ton of force. And I'll apply this to each one of those arms. So essentially that's a distributed load. The final product will have about 400 kilograms of force applied to that. So I'm going to apply exactly in the same process. It should keep most of the settings, at least the angle of that. We could probably just come in and adjust that as well if we needed to. I believe the other one was at 195. Perfect. And again, we can come in, change that to ton of force, and set that to 0.2. And hit OK on that. So that's essentially that arm over there. And obviously we want to apply a load for the wheels themselves. So we're going to do the same thing on that. And essentially we're just going to come in, apply the loads, make sure that this entire bracket over here In fact, I'm going to apply this to all of the inner faces, and this will essentially apply the load as if the pin was pushing against the geometry there. And we want to set this to probably also about 0.2 newtons per side, so 400 kilograms or so for the entire load from the wheel pin for now. We could always come in and adjust this at a later point as well if we wanted to, but for this particular study, I'll just put it as that. So again, same thing, normal to the faces, 0.2 tons of force. I think I need to change the other one quickly. Make sure if you do need to change any of them, you can find them inside of the loads. You can edit here. Yeah, it hadn't changed that too. Ton of force, so let me change that here. Oh, and then what we'll also need to do is account for some of the movement. So obviously, just the pin on its own here will act on the geometry that's inside here. We'll probably have some pulling and pushing from the wheel itself. So we need to be able to account for some of that as well. So we'll probably apply a load to the outside of the pin. And we're going to set that direction to about there. Maybe adjust the angle a little. Probably go a little lower than the previous ones, maybe about 100 kilograms of force in that direction, and then probably about the same in the opposite direction. Cool. And essentially, it's just a case of continuing through that process until you've got all of the loads assigned onto the different components, and just taking into consideration the different loads that you'd expect this part to go through. So once you've told Fusion all of the loads that you need it to be able to go through, what you'll then want to do is set objectives for the study itself. So if we come into our objectives, we've essentially got two options available to us. We've got the first one, which will be to minimize the mass. And these two strategies essentially define the way in which Fusion handles the study itself. So the minimizing of mass will start with the biggest, bulkiest design it can find, and then slowly take off as much of material as it can until it reaches that point where it no longer thinks that your part will be able to withstand the load given to it. And with that, we've been given a safety factor. So obviously, you can set this to whatever safety factor you want. And so that'll be 2 times, it'll stop the generation of this when it reaches about 2 times the mounted pressure that it reckons it could survive. The other option is just to maximize stiffness. So that'll essentially go the opposite way around, where it starts with the smallest possible bit of geometry and then builds it up until a certain point, and that certain point will be our mass target. So you can set it that way around. And then it'll essentially do the same test. So it'll start with some geometry, run a test on that, see if it survives. If it doesn't, add a bit more material, add a bit more flesh to the design itself, and then run the test again. So it's continually generating it, testing it, generating it, testing it until it comes up with a final design that it's happy with. For this particular one, I'm just going to set to minimize mass and put a safety factor of 2. Don't worry too much about me not applying all of the constraints to you. I have run another study in the background, so we'll jump straight to those. The next section over we've got is the manufacturing. So these are the different options we have for manufacturing this item. We've got quite a few options available to us. The first one is just being able to estimate the cost. If we enable that, it'll ask us how many what our production volume will be. So how many pieces of this particular object are we making? And then it'll it'll take into account different factors for creating the model, whether it be obviously if you're doing it on a bigger scale, you can put a bit more into the groundwork of setting up some of the dies, some of the machining and all of that. Otherwise, if you're only making a few of them, it's probably worth doing a few simpler models that require a lot less setup. So you've got that option available to you. For this one, I've just selected unrestricted so that we can also just see what Fusion can come up with. And maybe we see some ideas in that we can use in one of the other processes and refine that a little further using our own experience in that. So you've got that option. So you don't have to fully depend on the generative design. You can add in your own elements as well. And then the next section, obviously, we've got is additive. Pretty self-explanatory. You can pretty much 3D print that. You can set the orientation of the model itself or of the additive design itself. We can include all 6 directions, and that will essentially create a study for each of the 6 directions as well. And you can see which one works out best in the long run. We've also got the ability to add milling, so that's any of the CAM functionality. We can configure this to either a 2.5, 3, or 5 axis machine. And again, we can add in other configurations as well. So you can have multiple at once. So if we come in here and actually set in a study for the 2.5, the 3, and the 5, then we can see which one works best for our final design. Again, we can include all 6 directions. So with one study, you can actually get quite a few iterations of the same model and just changing the different manufacturing methods. So for the 3 axes, you can select all 6. For the 2.5, you'll just need to obviously select one of the tool directions. In this case, I'll probably select, let's see, Z. Or Y, one of the two, doesn't matter. We've also got the ability to set the 2-axis cutting or die casting, and you can add all of these to the studies itself. So for the one I did earlier, it was essentially going to be the unrestricted, the additive, and the milling. We can have a look at that, the other options at a later time as well. So once you hit OK on that, the last thing we'll need to do is quickly assign which materials we want to include as part of the study. These will be built-in materials from the Fusion library. You can also create your own material library as well, but it's probably best just to use the Fusion ones because those are the ones that have all of the properties that would be required for most of the studies themselves. So we've got an additive material library, we've got a non-linear material library, but we've also got the main Fusion material library, which is where I've selected my materials from. And if we expand that up, we can see they've been broken down into their different categories as well. From here, I just went into metal and we can select a few different options for our study. I like to always just add an aluminium just to see what interesting shapes we can get out of that. So just grab and drop that into our study section over here. You can pretty much assign up to about 5 materials per study as well. So my recommendation is just put as many as you can into a study and see what we come up with, whether it be different variations of similar materials or whether it be completely different ones. So I'll put in a wrought iron. I'll put in a stainless steel. And finally, for the fun of it, let's put in some titanium. Awesome. So we've got about 4 or 5 materials in there. I'll probably expand that, but I'm not going to now. And once we've done with that, we can essentially go into our pre-checks. This will essentially make sure that we've met all of the criteria we need for Fusions to generate this. We can see we've got a few errors here. The 2.5 axis doesn't support the preserve bodies. That's okay. We can pretty much ignore that. It will essentially just not generate the best results for the 2.5. For this one, I'm not too worried about that. If that was an issue for you, obviously have a look at the errors that do come up. And then this one just saying that the object will be a bit too big for the 3D printed, that's okay as well. We can then go and preview the model itself, what is most likely to be generated. So just hit that little preview button, and you'll start to see a little bit of a gray blob start to appear, and it slowly runs through a few iterations of what is possible with this, given our current criteria. You can see it starts to give us a bit of a bone-like structure over here. It won't render all the way through, but it gives us a good indication of what is possible from the study itself. And this is a great point to have a look at your study to make sure that it is avoiding the areas that you want to avoid. If we obviously we can enable the obstacle geometry from within here. And if you can see any areas that might be a bit of an issue, now's the time to make sure that that is all set. So once you're happy with that, in this case, I'm happy with that. So I'm just going to stop the design of that, or the preview of that. And all we need to do from here is to go into the generate option. So essentially, it's just a case of selecting generate. It'll give us the study options that we have available to us. So if you had multiple studies that you wanted to run through, you could select them from here, and then you could generate the study. I'm not going to go through this section now. I'm just going to jump straight ahead to some of the results that have finished for us, just so you can get a good understanding of what has been created before, using pretty much the same setup as we have here. So I'm just going to find the correct one here. I believe it was this rear suspension swing arm, and you can see pretty much the same, a very similar setup, albeit maybe the obstructive geometry is slightly different, but more or less the same thing. And you can see once we've gone through our generate option, in this explore generative design results is essentially where we'll start to look at and have a play around with some of the results that we've managed to get out of this. So I'm just going to change the manufacturing method once it loads up. Might take a little while. There we go. Cool. So we've got our 5-axis, we've got our unrestricted and our starting shape from within here. So you can see if we wanted to, we could narrow down some of these options. So if I uncheck these ones, we can see we start off with some of the unrestricted options. To preview each of those, we can pretty much just select them, and we're given the 3D model directly from here, and you can see some of the really cool designs that have come out of that. So this is again the unrestricted. From here, our properties on the side here, it'll show us the material that was used to generate this. You can see we've been given a volume and a mass. This is currently sitting at about 2 kilograms, so probably quite a bit lighter. I didn't check the swing arm itself. We can double check that in a sec, but quite a bit lighter than that. Obviously want to create a bit of a stress view of this just to make sure we know where the stress points are, and maybe areas if we did want to go into the manufacturing of this where it's most likely to find some issues. And it seems pretty solid from here. We could probably run a few extra tests on this using some of the simulation at a later point as well. But generally, Fusion is obviously running those tests in the background anyway on each rendition of your model itself. We could also come in here and compare this particular model to any of the other ones that have been generated as part of this list. So I want to try to find one that's a little different. Copy this one down here. Okay, that, and have a look. So you can see as we move the one, yeah, they're very similar except for maybe these arms over here. And as you move the one around, the other one moves as well, which helps you to analyze those. That's pretty much got a gap over there, so it might not be worthwhile having that entire arm there, but you can see if you wanted to change the model at some point, you could do so. And yeah, you can have a look around and compare these. Inside of this view itself, we can show where all the preserved geometry was. It's probably inside the model itself, and where all of the obstacle geometry was as well. Doesn't seem to be showing this. Finish that and just deselect this one quickly and go back into that view. Will it show me? We can turn on the preserve. There we go, and you can see where all the preserved geometry was and where all the obstacle geometry was. So you can see this is the area in which we are keeping open for the suspension, and this is the area we're keeping open for the wheel itself. you can see how it avoids those areas and just creates a nice structure that sort of intersects those open areas as well. If we go into the 5-axis, you can see we can add those models to our list here. I think this has probably been my favorite one out of all of the results so far. If I go back into the compare the two next to each other, once it decides to load up. This does seem to be a little slow at the moment. Apologies for that. I'm going to finish. I can check that one. And then just see if we can just open this one. It might help a little bit. Yeah, there we go. You can see it very much looks like a bone. And what you will notice is the more you use generative design, a lot of the objects that are created look very natural, as you can imagine. They've sort of been evolved as it kind of goes along the different processes. So you can see how the nice smooth lines, obviously to add to some of the structural integrity of it. With this particular one, you can notice how they kind of go in the opposite direction to each other to balance the opposite side out. So as the back arm goes up on the top side, the bottom one goes towards the bottom, just to balance out everything, which I found quite interesting. So once you're happy with that final result, and you want to use this as part of your final design, you can come in here and you can get your design from the outcome itself, or you could get a mesh from the outcome, depending on what you want to get out of this. So I have gotten the design from the outcome. You can then save that as an independent part, and we can then apply that into the assembly itself. So I'm just going to finish this off here and close off our Explore here. I'm just going to open up that part that I want to apply this to. So back inside of this one, you can see here are some of the results that I've managed to get out of that study itself. So just want to make sure it's this one. It's the 3-axis over here. We've also got, as you can see over there, we've got one of our first outcomes of this particular one, which again looks very similar, very organic looking, and then a few extra options available there. What I do want to do quickly is just show you the entire assembly all together, just so we can have a nice look at what the final product would look like. So we've got this rear suspension, which we started off the presentation with. What I want to do with this one is bring in that 3-axis generative design outcome and just plop it straight into our model here. You can see where the existing one was and where this one now replaces that. What I'm going to do is turn off the swing arm from here and just okay that, and you can start to see how that would look as a final product. Bearing in mind there are a few little issues with the lining up of that, of some of the geometry there. I'm just going to apply a quick joint between those. And that's okay. Hopefully it doesn't break it. Yep, all good. Sort of all good. If we move this about. I'm going to undo that. Doesn't matter too much. There we go. Cool. So more or less lines up. That's fine. What I'm going to do is quickly save this. So you can see we've got our alignment correct over there. If I save this as generative design added, what we can then do once that finishes saving, we'll be able to open up this original part here. If it will let me, let's create an offline cache. It should have been there. I'm going to close a few files just to make sure. This one's not any updates. I'm just going to close this without saving. Same as this one. Let's see if it will allow me to open that up now. Seems to be a little happy about opening that. I suppose it doesn't help that I've got so many things going on in the background here. Apologies for the delay in the internet connection.
While you're waiting for that to open, Cameron, I've got
Yeah.
the questions come through.
Yeah.
If I may, just to fill the time that's taken to download and open that model. So I think as these have been coming in, some of them you've just answered naturally.
Okay.
When you've been going through, but I'll start with a question from Jake. So during your presentation, you were editing the part and essentially adding new geometry for both the preserve and obstructive. Can you reuse geometry that already exists? For example, when you added the tire, could you have just brought the tire in from the assembly and said that is obstructive geometry?
Yeah, you very much can. So any geometry that's in the model itself can be used as part of the study itself. It can just be assigned as either preserve or obstructive geometry. What I would say though is you want to try to keep the preserve and the obstructive geometry as simple as possible. So if you were going to be bringing in the wheel, it might add a lot more complexity to the final study. So you want to keep the geometry as simple as possible and push that into the study itself.
Perfect. Thank you, Karen. And another one from Jody this time. I'm using Inventor Professional for my modeling rather than Fusion 360. Am I able to tap into generative design using my Inventor models?
Yeah, you can. So Inventor does have a send to Fusion option where you can essentially just send your entire model into Fusion, and then you'll be able to pick apart your design from there, much in the same way as I've done with this assembly. And we can, just apply that, make any tweaks you want to before sending the study off. And then you've got your model there. And then this whole model, the generative design model can also then get pushed back into Inventor if you needed to. Using either step file or any of the other export options, really.
Perfect.
It does seem to be taking a little bit of time.
Looks like it's not going to.
No. Do you want to, does Simon want to come in and
just
finish off? Let's get back to that.
Thank you, Cameron. That was awesome. I hope you all agree. And sorry, we're 5 minutes over schedule, and I hope it was worthwhile though, but because I certainly learned a lot from that presentation. Now you've sort of seen that it's quite a lot of setup to get there, but if you think about the old way of doing it, which is design, simulate, change, simulate, change, simulate, where Fusion just does it all in one hit with generative design. Awesome technology. I did notice a question that I tried to answer while Cameron was presenting from one of the chaps online, but I thought it might be relevant to some of you also might have the same question, which is the cost, the price of Fusion. Basically, Fusion, but generative design. So generative design can either be done using 33 cloud credits, and like I said to you earlier, you can buy a pack of 100 credits. I think £105, so they're basically a pound a credit, so about 35 quid, something like that. Or a year unlimited Fusion is about £1,500. Now, like I said to you earlier, there is currently a promotion on where it's about £1,000, but normally it's about £1,500, completely unlimited amount of generative design studies as you want in a year's period. There was also a question about training. So we obviously do deliver training and support services for Fusion. If you're interested, please get in contact. The main phone number here is 01844 263 700. I'm simon.brand@manandmachine.co.uk, or you may already have a Man and Machine account manager. Just get in touch with them. But without further ado, I'll finish the webinar today. So thank you for spending the time with us. Hopefully you found it useful. We've done lots of sessions like this that are all available on our YouTube channel. Please go and subscribe to our YouTube channel and like and comment on our videos, and watch out for future events that we're doing in the coming weeks and months. Thank you for your time. Thanks for joining us. Goodbye.